Okay, good evening everyone. Today our topic is motion in a plane with constant acceleration. Yes, so here as the name itself says, what is meant by constant acceleration? Yes, where the rate of change in velocity is at constant means the acceleration of it will be constant. That means the rate at which velocity changes will be same. So at that time we get the motion of a body with constant acceleration, isn't it? So here this is not any different topic. If you understand the heading, it is very easy to discuss. So again and again, look at the concept name at first. What we are studying in today class, we are studying for motion in a plane. Motion in a plane is nothing but motion of an object in 2D. Okay, two-dimensional motion of an object. Okay, so where it is possessing some constant acceleration means what? The change in velocity. Otherwise, the rate of change of velocity is remaining constant. Okay, so that is what constant rate of change in velocity is going to result in motion in a plane for a body with constant acceleration. Okay, so now, yes, in the last class we have discussed about velocity and acceleration in the two-dimensional motion. In the same manner, we have to discuss now for equations of motion of a body, okay, which is moving in a plane with constant acceleration. We will be writing some equations and afterwards we will solve some numerical, and after that we will go to next concept, that is projectile motion. Okay, so yes, just concentrate. I think all of you have got the heading name, what we are studying, that is done. Okay, so now here, let us assume that as the body is moving, I have taken as the body is having its motion in a plane, I have taken XY plane. Let us take the body is moving in XY plane. Okay, now let me take the velocity of the body as V naught at the time t equals to 0. Okay, so at a time of t equals to 0, the body is possessing its velocity as v naught. Okay, now the velocity of the body is v at any instant of time at a time equals to t, at a time t equals to t again. So at a time of t, at any instant of time t, the body is possessing its velocity as v. Okay, so at time t is equals to 0, its velocity is v naught. At time equals to t, its velocity is v. Okay, now so here we are discussing for constant acceleration at particular interval, the average acceleration will be becoming constant acceleration. So for that we will write down expression over here. We know that acceleration is nothing but change in velocity with respect to change in time. Otherwise, for a time interval, how much change in velocity is taking place, that is nothing but acceleration, that you all know. So I can write change in velocity as final minus initial. So what I have taken v minus v naught. So if you want, as I cannot show you bold letters over here, I am keeping just vector over the letter. In NCERT it is given with bold letters. I said already. Okay. So wherever there is written bold letters, you have to understand that is nothing but vector quantity. So here, vector v minus vector v naught divided by what is the change in time? Time is changing from t is equals to 0 to t. Time is changing from 0 to t. So t minus 0 will be t. So change in time, shall I write as t? Isn't it? So I'm not writing any vector. Time is not a vector quantity. This you all know. Yes. So here, acceleration is v minus v naught divided by t. Change in velocity is, initially velocity is v naught. Afterwards it changes to v in a time interval of t. Okay. So change in velocity v minus v naught by t. Now, so let me go for the next step. Vector a into t is equals to vector v minus vector v naught. I can write like this. Be the same thing. Now, so what is vector v at a time t? Vector v is equals to what? V naught. Vector v naught, take this side, plus at, isn't it? So vector v is nothing but vector v naught plus at, where v is the velocity. at an instant of time t, and v naught is nothing but the velocity at time t is equals to 0, and a is the acceleration, t is the instant of any instant of time t. Okay, so now here, if we are writing the same in terms of components, so remember we are studying for motion of a body in a plane, motion of an object in a plane, and I have taken xy plane. Okay, so let me write this equation in terms of x and y. So I can write vector vx is equals to, in terms of component. Okay, try to understand in terms of components. So what are the components I have to take in terms of the components x and y? Okay, so v naught, instead of v naught x plus vector ax t, or you can directly write vx is equals to v naught x plus ax t, like that also. So now what is vy? Vy is equals to v naught y plus ay t, isn't it? So these two are nothing but the components of vector v over here. So if I have written x, means I can remove here vector notation. It is understood that. So I have written along velocity along x-axis is equals to v naught x plus ax into t. Velocity along y-axis is equals to v naught y plus ay t. Nothing I did over here. I have just written the velocity vector in terms of x and y components. That's it. Okay. So we are studying for motion of a body in 2 dimensions, and I have given the velocity when the acceleration is constant at x and y components, as x and y components. Okay. So now this is what about the velocity by taking acceleration constant. Now moving to next. So what about the change in the position? So to study change in position is nothing but it is displacement. So change in position, how the position is changing. Okay, so during the motion of the body. So for that, let me take r naught is the position vector of the body at a time t is equals to 0. Okay, and now at the same time, let v naught be the its velocity. Okay, so let r naught be the position vector of the body and v naught be the velocity of the body at time t is equals to 0. And now let r be the position vector of the body and v be the velocity vector at time t is equals to t, or at a time t you can write. Okay. So now, so for finding the change in position, we are following here one dimensional motion. What you did in straight line, the same thing we can follow over here. So we all know that change in displacement, otherwise change in position or displacement can be written as that is equals to v average into time. Okay, average velocity into time. That is nothing but change in the position, or you can write displacement vector r minus vector r naught. Try to understand what I have written. So velocity is nothing but change in position with respect to time. Otherwise, displacement divided by time is nothing but average velocity. I have taken displacement is equals to average into time. It is the product of average velocity into time. So now, how to write average velocity? So what is the average velocity over here? Vector v plus vector v naught divided by 2, isn't it? Isn't it? So what is the average velocity here? Vector v naught initial, it is final, so I can write vector v plus vector v naught divided by 2, and time is t. And here the change in the position or the displacement can be written as vector r minus vector r naught, isn't it? So now let me simplify again. Yes, what we have got for vector v is equals to vector v naught plus vector a into t. So write down. So vector v is nothing but vector v naught. Here vector v is equals to vector v naught plus vector a into t plus what we have again, vector v naught divided by 2 into t. Okay, so now this is nothing but displacement vector r minus vector r naught. Change in position is nothing but displacement. So now you see Again simplifying, vector v naught plus vector v naught is nothing but 2v naught, okay, plus 80. Look at the equations, divided by 2 into t. Is it clear? Nothing, only simplification. Okay, so I'm just simplifying the terms. So v naught plus v naught, 2v naught plus vector 80 as it is divided by 2 into t. So now, moving to next. Again simplify it further, what you can get? Vector 2v naught divided by 2 into t can be written as vector 2v naught divided by 2 into t plus vector a divided by 2 t into t can be written as t square, that is vector r minus vector r naught. Okay, so the same thing again, what we get, vector r minus vector r naught is equals to, what is this, vector v naught t plus half vector a into t square, 1 by 2 into vector a, 1 by 2, take r naught this side, vector r naught plus vector v naught t plus half vector a t square. Okay, isn't it? So next thing, look at this carefully. So we have taken r vector r and vector r naught as the position vectors of the particle at two intervals of time. At two time intervals are t is equals to 0. When t is equals to 0, its position vector is r naught. When t is equals to, when time is equals to t, then the position vector is r. Okay, so the position of the particle is given by vector r. So there the velocity is vector v, and initially when time is equals to 0, the velocity is vector v naught, isn't it? So all of you know about all the terms in this. And here, look at that equation. If we go for velocity by using that, here we have taken one-dimensional process to derive this equation. So here I can write vector v as vector dr divided by dt. So here, what happens if you just differentiate? Look at this. What is vector r? Vector r naught plus vector v naught t plus half vector a t square, isn't it? So here, d by dt of r naught. So it is a constant. What we will write, it is 0 plus d by dt of vector v naught t is nothing but vector v naught as it is plus. So d by dt of half a t square can be written as 2 into half a t, isn't it? So 2 by 2 get cancelled. What you can write? Vector a t. So look at this expression, what we got. Again, it is going to satisfy the two-dimensional equation what we have derived at first. What we got? Vector v is equals to vector v naught plus vector a t. So by using one dimension, we have proved the same thing. By applying to the two dimension, we can apply. For one axis, see here, vector v is equals to vector v naught plus vector a t. Isn't both are same? What we got? We got for position vector r. So I have derived for vector v. Vector v is nothing but dr divided by dt. Taking differentiation of that, we got vector v as vector v naught plus vector a t, isn't it? So now look at this equation. So here, see, it also satisfies the relation. Look at this. It also satisfies the relation vector r is equals to vector r naught when t is equals to 0. Substituting this equation when time is equals to 0. What will you get? Vector r is equals to vector r naught. So you can see by these two things, by taking vector v is equals to vector dr divided by dt, and by taking vector r is equals to vector r naught, we have proven by taking time is equals to 0. So we can say that we can write by using this, we can write this one-dimensional equations along the two directions x and y. So x direction and y direction. So two one-dimensional equations can be represented or can be studied to get into the two-dimensional motion. That means I need to say over here, listen. Let me write the equation first so that you will come to know. So for in terms of components, the same thing. In terms of components, what I can write? In terms of components, vector r for x-axis, what I can write? X is equals to x naught plus vector v naught t plus half a t square, or you can write here v naught x also. Okay, so now for y is equals to y naught plus v naught y t plus half ay t square. Again and again I am saying, if x and y you have written, you can remove the vector, or yes, look at these things. I have written the equations along x and y direction, equation of motion along x and y direction by using this position vector r naught v naught t plus half a d square. The same thing I have written applied for x axis as well as y axis. So here, by using this, I can say, by looking at these equations, I can say the two-dimensional motion of a body, can be studied by using the two one-dimensional equations, simultaneously. So this is what an important result we have got. So by, see here, what I'm trying to say is, listen, by using one dimensional equations, we can study the motion of a body in two dimensions. So here we have to use these two one dimensional equations simultaneously if you want to study the motion of a body in 2D. So the same thing we are going to apply in our next concept. Okay, so how we are going to study the two-dimensional motion of a body by using one-dimensional equations. Okay, so here I have tried to give you the thing, that the result, important result, that by using two one-dimensional equations. So this is one equation, let us assume this is one equation along equation for y-axis, this is equation for x-axis. So here, if a body is moving in two dimensional, okay, so two dimensional coordinate, otherwise if a body is moving in a plane, okay, along xy plane, then I can study the motion of the body over here in this plane by taking the y axis separately, one dimensional motion along y axis and one dimensional motion along x axis simultaneously. If I take, I am eligible to study for the motion of a body in two dimensions. So these are the equations along x and y axis. I hope it is clear to you all. The thing is, these derivation they won't ask in exam, but these expressions are very much important for deriving the next expressions. Okay, so for next derivations we have to use all these things. Getting, so the main thing is x along x and y. What is the equation? See, if we are taking from the origin, this x naught and y naught will be taken as 0. If we are studying for from the origin, x naught and y naught, you can take it as 0. The remaining you have to write. Okay, and in some books they will be giving, instead of v naught x, instead of v naught, they will be giving you here v naught, wherever v naught is there. Instead of v naught, they take initial velocity as u. Okay, here final v I have taken, initial I have taken as v naught. So if it is written in terms of u, then it is representing v naught only. So do not get confusion. Okay, so this is all about the motion in a plane with constant acceleration. I hope it is clear to everyone. Yes, next we will move to next concept. So remember those last two equations, that is equation of motion for displacement along x and y. Okay, if you have NCERT, just open the book. We are going to solve next numerical. The example 4.5. We go to the example 4.5. Try to read the question. Try to read the question and understand it properly. See what they are asking and what is the given data. Write it down one side. Read the question properly. Read twice. I hope all of you are referring NCERT for next numerical now. So from last 2 days, whatever we discussed is just vector notations. That means the terms which are very much required for studying vectors. Are in kinematics as vectors is most important. We have done with that. Okay. So for this topic, let us go to a numerical over here. In example 4.5, they have given a particle starts from the origin at t is equals to 0. So I say now only from the, if it is from the origin, I say what to take x naught, y naught. Okay. So a particle starts from the origin at t is equals to 0. Example 4.5. Okay. So at t is equals to 0, it is starting, the particle is starting its motion from the origin. Okay, now the velocity is given as with a velocity of 5.0 I cap meter per second. So the velocity is nothing but v is equals to 5.0 I cap meter per second. Next thing, and moves in xy plane under the action of force which produces a constant acceleration of. That means the body has started its motion from the origin, okay, at a time t is equals to 0, and it is moving with a velocity of, that means initially it is moving with a velocity of 5.0 I cap. Only I cap is there, you can see. Okay, so it is moving with a velocity of 5.0 I cap meter per second. And now the force acting on the particle on the body is producing an acceleration of how much acceleration it has given. So producing a constant acceleration of 3.0 I cap. So let me write the acceleration as 3.0 I cap plus 2.0 j cap. Okay, so meter per, unit of acceleration, meter per second square. Okay, now first thing what they are asking is what is the y coordinate of the particle at the instant its x coordinate is 84 meters. So they are asking for what is y coordinate. So what is y coordinate? Y is equals to what? At which x coordinate is having the value x of t is equals to 84 meters. Okay, now next one is what is the speed of the particle at this time. So this is the first bit. So second bit is what is the speed of the particle. Speed is nothing but v, we have to find out. So what is the speed of the particle at that time? That means, so whatever the time you get for the first bit, you have to use that in second bit. So at the same time, what is the speed of the particle? So they have asked you to find out. So look at this now. So now only we have got the expression for r. What we got expression for r here? So solution. I hope all of you have got the numerical. What they are asking is a particle has started its motion at a time of t is equal to 0 from the origin, and it is moving with a velocity of 5.0 I cap meter per second. And if there is a force acting on the body, so that its motion has got an acceleration of 3.0 I cap plus 2.0 j cap meter per second square. Okay, now at that time, what is the y coordinate? What is the value of y? Okay, and at which x is equals to 84 meters. He has given x is equals to 84 meter at that time, what is the value of y when x is equals to 84 meter? And next thing is, what is the speed, okay, with which it is moving at the same time? Okay, so now for that, let me go for the equation. What we got the position as vector r is equals to what? V naught t plus half at square. I said r naught is taken as 0. So v naught t plus half at square. That is what r. So let me substitute the value of v naught. What is v naught here? 5.0. As it is initial, I have taken it as v naught. 5.0 I cap time t as it is plus half. What is the value of a? Acceleration is nothing but 3.0 I cap plus 2.0 j cap into t square. So look at this. I have written for r of t as we know, now only we have derived v naught t plus half a t square. R naught is 0, isn't it? So that's why I have removed that. It was actually like this, r naught plus v naught t, isn't it? So now the particle has started from the origin, so I have taken only v naught t plus half a t square. So now what is the value of v naught? 5.0 I cap into t plus half as it is. Acceleration is 3.0 I cap plus 2.0 j cap and t square as it is. Now look at this. So let us simplify over here. So 5.0 into t. So 5.0 t I cap, I can take it as plus half of just 1 by 2 3.0 I cap, so multiply t square inside into t square plus 1 by 2 into 2.0 j cap into t square. So look at that. So just simplify. Here I can write the things which are having I cap. See here. So for these two terms, let me take I cap common. So 5.0 t. What is half of 3.0? That is nothing but what? 1.5, isn't it? So plus 1.5 t square. So I have taken I cap common. So these are along the x-axis. So I have taken I cap common now. So for just for separating the x coordinate and y coordinate, I have taken like this now. 1 by 2 into 2.0 is nothing but it is 1.0 t square. Let me write first into j. Okay, so now this is what we have got r of t. Okay, so now what is in this? What is the value of x and y? You can see, look at the expression. Okay, so here the thing associated with the I cap is nothing but I can take it as x component. Okay, so this coefficient of j cap can be taken as y component. So here let me write x of t as x of t is equals to what? 5.0 t plus 1.5 t square. Okay, so now for y, what is y component here left is 1.0 t square. Okay, so now next you see what they are asking here. So just we have derived for the position with along x and y. So now they are asking for what is the value of y component at which x is equals to 84 meter. Try to understand. They are asking for what is the value of y at which x is equals to 84 meter. So for that, to find out y, see here, they are asking for y, we have to find out y. So for finding out y, we have y expression as 1.0 t square, we don't know that. Isn't it? Here we don't know that. So for as we want to know the time, and here as we know the value of x is equals to 84 meter, so let me use this expression where here x of t they have given as 84 meter. So this can be written as 84 is equals to 5.0 t plus 1.5 t square. Why I am using this means to find out y, I need the value of t, but I don't know the value of t, isn't it? But I know the value of x, so let me put the value of x over here as 84 so that I can find out for t, isn't it? So now 1.5 t square minus always. So let me take 84 this side. So 1.5 t square plus 5.0 t minus 84 is equals to 0. Okay. So as it is in terms of decimal point, let me multiply this with 10. So to make this equation easy, so what I can write here, 15 t square plus 50 t, it becomes, isn't it, minus 840 is equals to 0. I know. So again, to make it further simple, let me divide this by 5. Why? Because you can see here by 5, by multiplying with by dividing with 5, you can get the equation simpler. So now whole equation divided by 5. So what you can write here, 3t square plus 10t minus, what I can write over here, 168. So write down 168, 840 divided by 5. 168 is equals to 0 by 5 is nothing but 0. Okay. So now just solve this equation by taking, just solve this equation by taking 28 and you can take here 10t can be written as 28t minus 18t, isn't it? So you will get 10t. So by using these two factors, just simplify this equation for t. After simplifying, you will get, just try, you will get, after simplifying, you will get t is equals to 6 seconds. Okay, so here our intention was to find out the value of t. Why? Because we have asked it for what is the value of y of t. So now, so here y of t is equals to what now? As we got t is equals to 6 seconds, go for this. By using this, as y of t is equals to 1.0 t square. So what is the value of t we got? 6. 1.0 into t square is nothing but 6 square. So isn't it? So that is 36 into 1.0 meter. So this is what the value of y of t at which x is equals to 84 meter. I hope it is clear to everyone. So just solve it by using these two factors. You will get the value of t as 6 seconds. Okay. So now substituting for t as 6, you will get y of t is equals to 36.0 meter. Otherwise you can use, so minus b plus r minus under root of b square minus 4ac divided by 2a. You that equation, that one for solving this. Okay, this one. So for solving this one, you can use that also. X is equals to minus b plus or minus under root of b square minus 4 is equal to a. Otherwise, you can take factorization method. That is t is equals to 6 seconds. You will get by both the things. So now we got for y of t is equals to 36.0 meter. And now we have done with the first part. Now they are asking for what is the speed at the same time. So what is the value of v at that time? At that time means when time t is equals to 6 seconds, what is the value of v? So how you will get v? If you do dr by dt, as you know the value of r, if we do v is equals to dr by dt, you will get the value of v. Okay, and after that just find out the magnitude of it. So here we have the value of r. Now we done with a bit. So now for b, they are asking for v. V is equals to, we know that vector v is dr divided by dt. Put the value of r over here. What is r? R is nothing but 5.0 t plus 1.5 t square into I cap. Okay, so plus 1.0 t square into j cap. See, look at these things. In MCQs, you have to solve like this only. Try to do. So now, take separately d by dt of 5.0 t plus d by dt of 1.5 t square I cap. So for both I cap, or you can generally write down. So plus d by dt of 1.0 t square j cap. Okay, so now look at this. What is derivative of 5.0 with respect to t? That is nothing but 5.0 as it is, put I cap, plus derivative of 1.5 t square. So what is d by dt of t square? Yesterday we have discussed. Isn't it d by dt of t square is 2t. 2t to the power 2 minus 1 is nothing but 2t. So here 2 multiplied by 1.5 will give you 3.0. Here also I cap. Okay. 3.0 t I cap plus derivative of again. So that will be giving you 2.0 t j cap, isn't it? So now I can write it as 5.0 plus 3.0 t I cap plus 2.0 t j cap. Now we got the expression for v. Okay, so they are asking you to find out what is the value of v. Okay, it is in the vector form, we want in magnitude form, isn't it? At the same time, so what is the time here given? T is equals to, we got t value as 6 seconds. One you will get as negative, as time cannot be negative, you can see over here t is equals to 6 seconds. So substitute t value as 6 seconds. What you will get? 5.0 plus 3.0 into t is nothing but 6 I cap plus 2.0 into t is nothing but 6 j cap. Okay, so now what you will get? The value as, so 3.0 into 6 you can do 18 plus 5 is nothing but what? 23.0 I cap plus 2.0 into 6, what you will get? 12.0 j cap. So t value we have substituted, isn't it? So now this is what in the vector form. We want the magnitude. I said yesterday how to take the magnitude. Just remember how to take the magnitude. Magnitude of vector v can be written as, if vector v is equals to vx I cap plus vy j cap. How you will write magnitude of v? Under root of vx square plus vy square, isn't it? Just go for it. Do fast. So what we have got vector v as 23 I cap plus 12 j cap. So what you will get? Magnitude of vector v is equals to magnitude of vector v, that is equals to under root of vx square 23 square plus 12 square. Look at that. Vx I cap plus vy j cap, it is in the form of vx I cap plus vy j cap. So if you want magnitude of it, what we will do? Vx square plus vy square. So if you want, I will write the expression. If v is equals to nothing but vx square plus vy square. The same thing we have done here. Now you see 23 square is nothing but what? 23 into 23. How we will do 23 square? So listen. To multiply fast, it is a Vedic math trick. You see here. First we have to multiply these two. 3 into 3, 9. 2 3 is a 6. Plus 2 3 is a 6. Okay, total it is 12. So write down 2 over here. So 1 carry. So 2 2 is a 4. Plus 1 it is 529. So how to do? When you have the same two numbers, square of the same two numbers, if it is big, how to remember? So 3 into 3, 9. After that, just multiply here. 3 into 3 is equals to 9. Next is 2 into 3 plus 2 into 3. Okay, how much it is? 6 plus 6, it is 12. So write down 9 here. 2 write down 1 carry. Again 2 to the 4. 4 plus 1 it is 5. So like this you have to multiply. So that is nothing but under root of 23 square is nothing but 529 plus. So 12 into 12 is nothing but 144. You can remember. Now what is 529 plus 144? So 600, 640 plus 30, 50, 60, 70, 673, isn't it? So 673. Okay, so just take out the under root of 673. It will be nearly equal to how much you will get? 26 meter per second. Not exactly. You will get nearly 26 meter per second. Why? Because you can do 26 into 26, it will be nearly 676. So near about answer is enough. That is nearly equal to 26 meter per second. That's why written. So this is about the example 4.5. It may look a little heavy for you, but if you practice, it will be easy. So just try to practice such numericals. Okay. I hope all of you have got this numerical. If it is so, we will move to next. So next, today what I'm going to discuss is very important for 5 marks in theory, many times asked, and for NEET, I cannot say more formulae are there for projectile. So you can, if you understand once, you will easily apply for MCQs. Okay. So try to do this once. The numericals. So never leave doing numericals in physics. Every day you have to do. Why? Because it takes time to learn. Now. So now we will move to next most important concept, that is projectile motion. And motion of a projectile. So here we dealt with constant acceleration. So whatever we are going to do next is nothing but example for motion in a plane with constant acceleration. Here we have got two cases. One is projectile motion, next is circular motion. So now we will move to next most important topic for 5 marks. Many times asked, that is motion of a projectile. So very easy, very interesting concept it is. Okay, listen now. Listen. Motion of a projectile. This is your next concept from last, the second or third concept from the last of this chapter. Very much important. Listen. So before going to study about motion of a projectile, we should know what is a projectile at first. See here, projectile is any object or any body. Okay, it is any body when it is being thrown, okay, at an angle from the x-axis or from the horizontal, okay, at that time. So when, see here, let me show you one example first, how it will act. Let me take, okay, see. As I am explaining for motion of a projectile, let us consider this as horizontal axis, x direction. So this is the x direction, okay. And now here I have got an object, okay. So if you want to see how a projectile will move, or what is a projectile, to which object we call as a projectile. So for that, so let me take from the horizontal an angle, okay. So at an angle, I'm just throwing this object. I have thrown this object like this, isn't it? So here, what has happened means, for a particular interval of time, that body was in air, okay, that body was in flight, isn't it? So here, that body which is in flight, which is moving only under gravity, okay. So motion of a body under gravity is called as projectile motion, and that body which is being projected, that is what called as projectile. I hope it is clear to everyone. Listen now. So by making an angle with the horizontal, if I am throwing an object by giving some initial velocity, I have thrown some object, isn't it? So that object is moving with some initial velocity, isn't it? So here it has got some angle from the horizontal, okay, like this, and I have thrown that object, okay, by making an angle theta with the horizontal. If I throw that object, means what is happening means that object is going to be under flight, okay, and it is moving under motion under gravity, okay. The motion of the body is under gravity only. That means the only Force acting on the body is acceleration due to, sorry, the acceleration acting on the body is acceleration due to gravity, and the force acting on the body is gravity. Okay, so here the body which is moving under the gravity only, that is what called as projectile motion, and that body which is moving is called as projectile, and that motion of the body is called as projectile motion. So listen again, this is most important topic. Just understand what we call as a projectile. So projectile is one, or it is a body, okay, so which is moving in air only under the influence of gravity. Okay, so we here, while studying for projectile motion, we are neglecting the external and any other forces like resistance, air resistance and everything. We are neglecting friction, air resistance, everything. Okay, so we are just considering the force acting on the body as only the force of gravity. Okay, and the acceleration acting on the body is only acceleration due to gravity. So if it is so, then that body is said to be under projectile motion. So okay, so it is possessing a projectile motion, and that body which is in flight is said to be projectile. Okay, so now whenever a body has got some angle, okay, with the horizontal, and whenever it has got some initial velocity while throwing, okay, so after that we are not going to give any external, it has to be only under the force of gravity, then such motions is called as projectile motion. Example is nothing but, okay, so for that example is, you know that a cannon firing balls. So when cannon fires balls, so at that time the balls are moving only under the gravity, isn't it? So that motion is example for projectile motion. Okay, so football, that is also taken as projectile motion. Okay, motion of the football, isn't it? So when it is being hit by the man, then it is also an example for projectile motion. Okay, now just imagine you are standing in the cliff, or you are standing on the mountain, and now just you have thrown some ball or some stone at that time, that is also said to be under projectile motion. Okay, so this is just introduction for the projectile motion. Okay, so if you want to ask any doubts about yesterday's and today's class, you can ask. Yes, see here. The question number is 4.5, example 4.5 it is. Here what they are asking is, yes, I can understand it will be a bit difficult for you. Why? Because there is differentiation, and that's why. Just practice those formulae which I have given in the last class, and also we have discussed it first. At first of the first year classes when we have started, then we have given some differentiation formula, isn't it? Just practice those. For solving that, listen now. Let me give some differentiation formula which are important for this. Uh, See, if we take differentiation of x with respect to x, dy dx of x can be written as 1. Okay. So if we take dy dx of x square, okay, that is nothing but 2x to the power 2 minus 1, that is 2x. Okay, so here the thing is, the general formula is d by dx of x to the power n. Okay, so that may be 1, that may be 1, 2, 3 or anything. So differentiation of x with respect to x, so that can be written as n into x to the power n minus 1. Formula is, general formula is n into x to the power n minus 1. So now here, if I have taken d by dx of x, means here n value is 1, it is understood. So 1 into x to the power 1 minus 1 is nothing but 1 into x to the power 0. So anything to the power 0 is nothing but 1, isn't it? So next is d by dx of x square in the same manner. Here value of n is nothing but 2. So how will you write? N into x to the power n minus 1. So 2 into x to the power 2 minus 1. Okay, so here value of n is 2. So like that, in that manner you have to solve. So for this numerical, only this much we need. If there is d by dx of ax, that means if a is a constant, and here whatever you have taken with respect to x, it is what called as a variable. So d by dx of ax can be written as a. Okay, so constant will be remaining as it is, and the differentiation of any constant, that may be a or anything. Differentiation of any constant. Constant means it is a number or any letter which represents the number. So differentiation of constant is always 0. So these are some basic formula of differentiation which you should know for solving these numericals. So here the question is, listen now. They have asked for a particle is starting from the origin, it has got its motion. It is starting from the origin and it has got its motion with an initial velocity of 5.0 I cap meter per second. So here initial velocity what I take, v naught is equals to 5.0 meter per second. Okay. So now here next, and it moves in a xy plane. It is having its motion in xy plane under constant acceleration they have given. So now only I have given the equations for constant acceleration, isn't it? So now in concept we have derived the expression for x and y along x and y axis. So now when the motion is for constant acceleration, and now here the value of acceleration is given. A is equals to what? 3.0 I cap plus 2.0 J cap, isn't it? So acceleration unit is meter per second square. The body is starting its motion from the origin, then it is understood that x naught and y naught are 0 at that time. So x naught and y naught are 0 and initial velocity is this much and the acceleration is by c. Due to some force it has got acceleration. Okay. So now here they are asking for what is the y coordinate of the particle. So they are asking for what is the value of y of t when x of t is equals to 84 meter. Okay. And next they are asking for what is the value of speed of the particle, what is the value of v. So these two are asked. So try to understand before solving any numerical. You should go with the question once or twice. Listen properly. So here they are asking for y of t when x of t is equals to 84 meters. So to find out y and x, we need first what is the value of r of t. So here we know that r of t is equals to, we have got r naught plus like that. So as it is starting from the origin, I can write here r of t is equals to v naught t plus half a t square. So what is the value of v naught? V naught is nothing but 5.0. Here they have given I cap, 5.0 I cap into t plus half. What is the value of acceleration? 3.0 I cap plus 2.0 j cap, okay, into t square. That is what acceleration. Now, here what I'm writing is I'm just taking the coefficients of I cap. Okay, for taking C as I want x component, let me take the coefficient of I cap at one side. So let me write here 5.0 plus half of 3.0 is nothing but what? 1.5. 1.5 into t square. Multiply t square over here. What do we get? 1.5 t square here. 5.0 t and 3.0 by 2 is 1.5, multiply t square inside, I cap common. Okay, so now 1 by 2 into 2.0, t square is nothing but what? 1.0 t square j cap. What I did? 1 by 2 I have multiplied inside, t square I have multiplied inside. 2.0 by 2 is nothing but 1.0 t square j cap. Okay, so this is what the value of r of t. So here what is x component? So x is equals to, or x of t is equals to 5.0 t plus 1.5 t square. Okay, and now, so what is the y component? Y component is nothing but 1.0 t square, isn't it? So they are asking for what is y when x is equals to 84 meter. Okay, so here x of t is equals to, or x equals to 84 meter. What is the value of y they are asking? So for finding y, we should need the value of t, but we don't know the value of t. So that's why, as you know the value of x, substitute the value of x as 84 over here. So what do we get? What do we get by using this equation? 84 is equals to 5.0 t plus 1.5 t square. Okay, so this is quadratic equation which you have got now. 1.5 t square plus 5.0 t minus 84 is equals to 0. So for taking out the decimal, I have multiplied this equation with the tens. What you will get? 15 t square plus 50 t minus 840 is equals to 0. And again, making it further simple, I have divided it with 5. So what you will get? Whole divided by 5. What you will get here? 15 by 5 t square is nothing but 3 t square plus 10 t minus, so it will be 168. Okay, so 168 is equals to 0. So this is what the quadratic equation which you have got. For solving this, just take the factors 28 and minus 18, 28t minus 18t over here, and just you know the factorization method. So now by using that, what you will get is t is equals to 6 seconds. Okay, just substitute over here. 12 plus 28t minus 18t minus 168. Take the common, and you will get the value t as 6 seconds. So now, as they are asking for y of t is equals to what? 1.0 t square. So 1.0 t square. T square is nothing but 6 square, isn't it? So 36 into 1.0 is nothing but 36.0. So this is the value of y of t. Is that clear? So now next one is what is v? What is the magnitude of v they are asking? So we know that v is equals to dr divided by dt. D divided by dt of what is the value of r? R value is this one. Okay. So r equation just write down 5.0 t. Okay. 5.0 t plus 1.5 t square. Okay, into I cap plus d by dt of 1.0 t square into j cap. Okay, again, so here, so shall I rub this? Next is, again take differentiation. As I said, dy dx of x is nothing but 1. So constant will be remaining. For that, along with the constant, what you will take? Constant as it is. So d by a, take a as it is. Dx by dx it will be 1. So what you will write here? dt by dt will be 1. What is remaining? 5.0 plus. So 1.5 into 2 is nothing but 3 into t to the power 2 minus 1 can be written as 3t, isn't it? Into I cap plus d by dt of 1.0 t square can be written as 2.0 t into j cap. Okay, so this is what we have got the value of v, and we got the time t as 6. So substitute here. At the same time, they are asking what is the value of V at the same time. So T is equals to 6 seconds. Substitute T as 6. What will you get? 5.0 plus 3 into 6. What will you get? 18. 18 I cap plus 2.0 into 6. Write down directly. 12.0 J cap. Put the value of T as 6. Okay, next what will you get? This is 23 I cap plus 12 J cap. Okay, and what is next further procedure? Which is equals to under root of, if you want the magnitude of vector V, it is in the form of Vx I cap plus Vy J cap. Write down Vx square plus Vy square. What is Vx? 23 square. Vy square is 12 square. So whatever you get is 673 something. 673 is nothing but under root of 673 is nothing but it will be nearly equal to 26. Solve for it. Okay.